And thanks everybody for joining this morning. So yeah, as Donna said, hope you are enjoying your coffee. I am enjoying lovely Dunkin' Donuts, so I'm not on the mature side of coffee at this point. But I'm from New England, so I'm used to it this side. So I'm actually one of the senior sales engineers for ThreatINSIGHT, formerly Iceberg. We were an acquisition by Gigamon back in 2018, falling into the category of network detection and response. So I'm going to run you through a little bit more. You're kind of agnostic to Gigamon, and you go through a little bit of a high level of the transitions that we've seen from most security operations teams and the tooling that they leverage in today's space, and really where network detection and response falls in line. Cool. So from this side, kind of a little bit of an abstract to this, right? So taking a look at, as SOCs have really matured, they've employed a number of solutions to combat cybersecurity threats. Traditionally, most SOCs have really relied on your typical SIEM and EDR tools for detection investigation needs, even filtering in general data points from your IDS perspective at your gate level. That's beneficial, but while these tools are critical to security operations, they have their limitations. Such as modern security teams have really turned to network for added detection visibility. Being able to actually get that pervasive, truth from not what's just detonating on your endpoints, but ultimately what's happening and how is the actual attack persistently gaining access across lateral movement inside your environment. So network detection and response solutions really provide, the necessary visibility not available in your traditional SIEM or EDR solutions. EDRs, they have great data that filters in, but a lot of the times what you find is that EDRs are very chatty. So to be able to actually help SOCs complete their security architecture, you really have to look at transitioning the data not necessarily just from the endpoint, but also laterally from network traffic. What's happening into your environment, and is there any malicious intent for some form of, say, exfil as an example? So really in this session, we're going to discuss traditional security architectures, how they're being optimized using NDR into an actual modern security team's tooling, really, if you will. So let's start the conversation about why we need the right data for visibility. If you're kind of taking a look at this, the different collection methodologies, from left to right, collecting, triage, investigation, corroboration, right? That's your typical triage process that most security teams are going to run through to be able to identify what's happening inside the environment. But we like to refer to a great talk from Tim Crothers, "Are Breaches Inevitable?" That was from a talk back in 2018, in which he really describes the defender's dilemma. Where do I look? What tools do I actually ultimately need to be able to actually expose this activity? And from at that point, how accurate am I actually detecting this activity? Like I said, traditionally most customers really looked at just having a standard antivirus with atomic indicators. That's a great start, right? But those are static, and they're going to be very noisy. And then looking at just your firewall level, you're going to get IDS logs, but how do you present those and how do you keep up with them as well too? Tim said, while preventing measures are necessary and should be implemented, they will also be invariable to fail. And that is pretty true for most customers you see in the news today, where you're seeing this person paid $125 million for ransomware. How did that actually get in there? How do they actually treat it? Were they able to respond to it, or do they have to call in a company like Mandiant to really deal with the roof when it's on fire? So when they fail, you need to have the right data to collect in order to really properly detect and actually investigate threat activities effectively inside your environment. So being able to actually focus on the narrowed down points, be able to actually pivot through the different types of data without having to really sprawl yourself across too many different tools is ultimately going to reduce your dwell time, get you the ability to actually figure out where we need to contain the specific exposure, and then go through the actual process of building out your documentation. Any good incident responder or SOC analyst is really going to make sure that they're good at documenting. That is like kind of the one-on-one to security. You can be great to utilizing tools. You don't know actually how to document and be able to present to the executive team as to why did this carry out. It's not going to be beneficial to you nor to the team that has to follow up from this. So when we focus on what happens after detection, we need the right data collected in order to validate the detection. Having the right data, the right kind of data is an essential part of triage and investigation. So taking a look at a traditional security architecture, right? Many companies, they have their shifts in as to what they're looking at, what they prioritize over time. But as attacks become more sophisticated, they start to mimic activity that you would normally see inside your environment. They become a little bit more slow and persistent. The traditional way is really not going to up-level you into the digital transformation that a lot of companies are going through, especially if you look at just hybrid networks alone. Just having something at the firewall or the gate level or having something at the endpoint is not going to get you the detail needed for actually inspecting that traffic. So traditional architectures of security products employed by many organizations, security teams seem to send every log they can think of into their SIEM for security analysis. This is where the data is going to be collected, stored, retrieved, and built for data validation. So while SIEMs, they're great for collecting and storing logs extremely well, right? That's their job. They take in general data points and they ultimately store it. But they were never actually intended to collect the vast amounts of event data. And they are built to scale, but you're going to pay for it, right? When you actually take a look at the event data, they can produce by that can be produced by both networks as well as endpoints. That's vast amounts, especially if you get into the larger enterprise networks. So furthermore, most orgs are extremely, for orgs that are extremely large size, their SIEMs tend to degrade, in performance because of the vast amounts of data that's needed to be searched through, right? And if you've ever had, the situation where you've actually had to search through large PCAP, files, large logs that are being sent over to the tool set, what you tend to find is in most cases, you'll run a query, whatever syntax essentially you're going through, or whether you're clicking through something, a lot of the times you'll actually have to go get a cup of coffee, like we're all doing this morning, and then come back and for it to tell you invalid search query or context. And then you're having to jump down the rabbit hole again, figure out where you actually went wrong, and redirect yourself to the target activity or event that you're actually looking for. So when you really start to take a look at being able to search through this data, this slow analysis investigation increases dwell time and it increases overhead for most security operations teams. SecOps teams tend to be overloaded. That defender's dilemma, like we talked about in the beginning. There's a lot of hats that they need to wear. There's a lot of ways that they need to go through their triage process. There tends to be some sort of mean time to detection and response. There's a KPI associated not only for the tool, but also for the individual person that's actually trying to vet this out. Is this normal activity in my environment, or is this something that might be just a false positive? Being able to vet that out is a lot of work. And if you look at the graphic that we have here, take a look at all the different types of log events that would normally filter into an event management system, like a SIEM. So where SIEMs do well and really where they don't. So it's definitely, so we usually say it's not always cheap. It's usually not cheap to store every event, right? Especially if you look at the different teams that require storage. So from the SaaS perspective, it might be a little bit of a less burden. But if your SIEM or your data collection, whether it's Elastic or whatever the vendor essentially is, if you're storing that on-prem, chances are you're probably tapping into a CapEx budget or OpEx budget, and those different silos of storage, you have to carve out a LUN, but that LUN could also overlap with your VMware team, your systems engineering team, your NetOps team. When you start to carve out things of that nature, you're actually conflicting against multiple different budgets. And for a security team, really, if you do want to send all of the things, it's not cheap. So for a small business and a mid-sized business, probably not a problem, right? A lot of the times they can dedicate storage resources. But when you get into like the larger orgs, they have so much data to collect and store, it becomes a cost burden. What's the total cost of operation to be able to actually get all these tool sets to feed the data in, associate brokers at each different data point, especially if you need to talk to a DevOps team and say, hey, I need to put a data broker on this, a heavy forwarder on this database repository, they're going to go tell you to take a walk. Because a lot of the times they're going to say, hey, you're going to impact my environment from not only mirroring this data over to your repository for analysis, but also it could cause problems where you're storing too much that's overlapping with what we're trying to do here. So normalizing event types, fields, timestamps, it requires a lot of maintenance and knowledge, especially of the different data types that you're actually trying to collect against. Accepting of like different data aggregation and correlation against that, but really when you get into detection engineering, it's not easy. If you were to have a security research team to actually start building out your own detections, 9 times out of 10, it's going to cause fatigue. It's going to cause employee churn. The reason behind that, it's a lot of work and you're asking them to take a lot of different data points. If you think about it, pulling in threat intelligence, you think about pulling in different types of query capabilities inside your platform. Also the maintenance of the tool itself. So response times, you're not hitting your KPI. If the roof's on fire and you've let that detection sit and dwell for too long, chances are the impact and severity has increased from, say, if you're looking at moderate to now severe. And how confident are you that you've actually detected all of the actual activity inside the environment? It's not always detailed enough to be able to get down to the extent. So creating detections requires usually specific knowledge, right? And expertise. You're going to know your environment, you're going to know your customer's environment fairly well, but being able to know all the nuances and the changes in different divisions, that's been an issue from just a business perspective. But when you get into the security side of the house, that's what keeps you up usually at night. Myself as a former incident responder, a lot of the times I would say, hey, I've cleaned up things, and being able to identify the different areas of where this actual compromise happened from. But what is the staff actually doing right now that potentially initially caused that response? What did I miss? So an example, right? It takes time and expertise to research a new detection tactic or technique, then prototype it, build a detection rule and test it for accuracy, and then tune as necessary. So you think about your baselining, your tuning, and at that point, do you have the expertise? Are you going to take a class? Where are you finding those resources to come in and help you? So in most, even with most well-funded security programs, you can fail due to slow response time. So as the security industry evolves, shifts in workload, especially from the work from home situation, you've got to recognize a new attack surface. Really, in most cases, most CISOs and most practitioners will agree that, people tend to be the most vulnerable, part of their network. Especially when you have kids, working on your work laptop, even though you choose not to, and it doesn't hit the, governance of your SecOps team or your CISO, it happens, right? And practitioners, recognize really the importance of using, specialized systems to actually collect, store, and analyze the data from networks and endpoints, right? Being able to identify what's happening, traversing the network from north, south, and east, west, and then ultimately what's firing on my EDR or my endpoint. These systems, EDR and NDR, they work complementary to each other. I use the example, with EDR, you're finding out, telemetry from the actual endpoint itself, what systems have potentially, been manipulated to say, hey, this is actually how it's supposed to work. But what you realize is the compiled code, they've changed something in the regex to inject, the capability to start doing key logging, right? That's definitely one point, right? And you're going to need to be able to collect the telemetry data. What process ran, when, where, by whom, and what did those processes actually do? Where NDR focuses is you actually focus on the level of being able to identify what happened when that threat launched on device A and went over to device B. Are there open IPC shares? That hidden share that Windows just decides not to get rid of. Past the hash, they might have fixed some of those situations where you're looking at specific credentials and things of that nature, but there's still always that need for security not to disable business needs. And that's usually what raises the focus. So how do I identify from a traffic, network traffic data, who communicated, when, what protocol was used, and what was the content, right? That sweet spot, not necessarily, it's the one that sits essentially in the middle. Being able to look at payload inspection, being able to actually take a look at file static analysis. Was this cat GIF image that was downloaded from the HR team and uploaded into their avatar for Slack. Was that malicious by intent? If you match threat intel against it and actually start doing analysis against it, chances are that cat gif actually was doing reconnaissance. It had a table loaded underneath it, but you'd be none the wiser. So being able to actually have NDR identify things of that nature that might be more malicious, but from an EDR standpoint, you might not be able to determine. So both are specialized systems. Really, when you look at it at the end of the day, they're designed to collect, store, analyze, and ultimately enrich the specific data that they collect. Each has their own visibility limitations, but together they complement each other very well. I kind of call them the peanut butter and jelly, really the yin and yang to each other. What's fired on the end host and how do they actually communicate across? Was there any open ports? What was the actual flow of the data? So looking at an actual improved security architecture, now we're bringing the pieces really together. How do we look at network activity? How do we look at endpoint activity? And then looking at the application logs, those general data points that really can only filter into a SIEM. So if we actually revise our traditional security architecture, we introduce NDR and EDR as the intermediaries between the network traffic and endpoint traffic. The NDR and EDR solutions store all specific telemetry data, enriching the security analyst to start identifying what is the system, who actually carried out what, and when was it actually carried out. And they're really designed to collect for analysis. And then ultimately you can feed a SIEM solution with a relevant detection and related important events. Having to go between the two different systems can be tough, right? You need kind of that, a little bit of a cringy term, but single pane of glass, and it is true, really, from, I know in our security realm, that can be a little bit of a tough phrase to consume, but it's true. You do need that single pane of glass. You need that one syntactical, change and the ability to actually report on it. So these important events really start to correlate on top of each other. The actual collected data across both the endpoint and the actual network detection. But then starting to look at the third-party applications, your LDAP security logs, things of that nature that would happen from your Infoblox units or your domain controllers. So taking a look at the visibility triad. So when you actually start looking at EDR and NDR, and this is something that Gartner actually looks at. Anton Chopnik, formerly from Gartner, really kind of built this out as to how can all three of these components help a security operations team, but ultimately just help all the other individual teams. I say when you start looking at threat hunting and other different ways of investigation, the best way to look at it is to talk to other teams. They're probably going to have more wealth of knowledge than you would have just kind of sitting in your security bubble. But when you actually start taking a look at these three operating within inside what Gartner calls the SOC, visibility triad, the EDR and NDR solutions perform specialized analysis of endpoint and network data respectively. And then ultimately you need to feed that relevant information, time correlation, log information, what's the name of the device itself, to the SIEM. Really for you to kind of shift that workload off of looking at those two individual tool sets and allowing them to actually make something visible to your team and ultimately reportable. And this basically makes the SIEM more efficient, not just sending everything and all the things over to your SIEM. It's not really going to correlate a lot of things that specialize when they're sitting in their swim lanes for NDR and EDR, the right data. And it provides the SOC team with the tools they need to really complete that visibility and coverage of their network for detection investigation of threats. Right? Where's that area of compromise potentially that would happen inside the environment? Where are those slow actors really playing out most of their activity today? So why NDR, right? Defining an actual network detection response. So let's take a little bit of a step back, right? We've talked a lot about NDR and EDR and the SIEM together, but specifically focusing on NDR. It's very necessary to actually incorporate an NDR into security architectures today. You're finding more and more customers actually starting to realize that area between east-west traffic tends to be the darkest, where they don't have a light shining in there and actually correlating data to it. Because with an EDR and a SIEM, they're not perfect. They tend to be very chatty. I know this from my former life of being able to feed an actual EDR and trying to correlate and identify what's a true or false positive. They have their great places. They're great at identifying changes in different way processes are actually working. But being able to identify if it's a true or false positive and how did it carry itself across the network, the EDR is not going to be able to really fulfill that need, and a SIEM's also ultimately not going to be able to correlate all of that data for me. So they have their specific limitations, when it comes to coverage for devices. So EDR relies on agents to collect telemetry data, right? Something that actually has to be installed, and we've all tried to do GPO policies to install agents. Has it succeeded? Has it failed? It's a tough one, right? It's a tough one, especially with a work from home, and help desk might be doing something now, which is the deprecated agent. You guys have switched over to a new different type of EDR, and they don't have the means to be able to update this. They require somebody to connect to VPN. It's a tough one to maintain, especially from the administrative side of the house. So SIEMs really rely on logs to be sent for analysis, and logs typically don't include the detail necessary to perform accurate threat detection. Dedicating a security research team in small orgs or even enterprise orgs is a tough one to actually hire for. So even building out your own threat detections tends to be tough. And you will get there, but it takes some time, and it takes full-time employees. So the solution is to turn to the actual network traffic, starting to shine a light in where this actual activity is happening. And as we mentioned before, when you send all your network data, net flow, metadata, et cetera, directly to the SIEM, which was not designed to handle that load and the level of events, it becomes unusable. Not to mention the fact it will cost an arm and a leg to store all of that data. Remember, the SIEM is not usually the storage point. The SIEM connects to a storage point. And if you're connecting to a pre-existing one or a legacy storage point and not in a project building out both storage and the presentation layer, it gets tough. It gets to the point where you're carving out only so much and you only have visibility into so much of the activity. So that's where NDR shines, right? NDR solves the issue that exists with EDR and SIEM, and the three together do make a perfect SOC visibility triad. Especially when you look at cloud services or SaaS-built NDR solutions, where the storage is not really the core component. You just rely on utilizing the tool and not worrying about how the administrative overhead really works. Especially when you start getting into the scaling problem. How much data can we send over to this? What are the NIC speeds of my actual data brokers to send this data over into my SIEM? So if we take things a step further, right, we can start to include the response aspect of NDR, the SOAR, to actually orchestrate and perform automated response, right, for security teams. And this is what we would consider a modern security architecture, really specialized tools necessary to make sure systems perform and operate smoothly. You really start from the bottom here and you start taking a look at the network traffic, the endpoint, the application log. That's where we began our story. Then you build an NDR and EDR to actually correlate the correct data and then feed that information over to your event management system. That's your presentation layer. Then you take in some other generalized data points for your DevOps team. Application logs, security transaction logs. Maybe you can't actually deploy an EDR on your Active Directory system, but what you can deploy is an actual heavy forwarder tapping into that and then forwarding those logs from a security transaction. Who logged into what? Maybe your AD is also running DHCP services and DNS services. Those are additional logs that you're going to need to be able to correlate. Your NDR and EDR can pull a lot of that detail in, but there are other ways to correlate the two different data together to really make the SIEM very powerful. When you get past your SIEM, you need to actually have the ability to start orchestrating, automating the actual response. So if you're not familiar with a security orchestration or automation response, let's touch upon that really quickly. Here. A lot of different vendors out there, so I won't really specifically name vendors. Let's stay agnostic to that. The job of the SOAR is to have the security analysts identify things that are the same. Ultimately actions from your individual tools of your NDR and EDR. How do they alert you? How do you go through a triage process? And in the event that you get to an identification of a severity or a confidence underneath a specific type of detection, from that perspective, you need to start taking a look at, okay, I've got these two different areas. my typical process is maybe I need to build an ACL to block traffic from this external host that's trying to interact with my DMZ box sitting on the outside here. Maybe I actually need to quarantine this device on its own right so I have a chance to investigate without it further spreading lateral movement. What I used to call, do I pop the box or do I not pop the box? Really what that means is, do I stop it from doing what it needs to do and pop it off the network? Or do I continue to let it do what it needs to do so I can figure out how much further has this threat actor done activity inside my environment? And then from that perspective, you can execute playbooks, which are built into your security operations system, your automated and response side. Really, the automation is to say, hey, this identified it, human interaction shouldn't be there. Respond to it by doing either creating an ACL, blocking the system, further actions from that. But really, that's where it starts to get into the full optimized actual security architecture. But we see a lot of traditional SOC teams really stop at the event management. SOAR is a big jump. It's a big leap. It's identifying the same things. If you look at your house, you know you're going to need to pay an electrical bill. You know you're going to need to pay your cell phone bill. How do you interact with those? You pay them, right? That's your tie a credit card to it. You extract essentially the data and then ultimately pay the bill. Think of that from the same architectural level of actually responding to a threat inside your environment. So really 4 main categories, especially defined by Gartner at this point, as to where NDR sits and providing actually detail for security analysis. It's the detection, identifying actual high fidelity threat detections, maybe taking a different approach than your typical anomalistic data points, looking at something a little bit more succinct as to threat actor, their tactics, their techniques, ultimately how are they interacting with your environment. And then automating an actual way to really reduce the mean time to detection. Not having so much overhead and really increasing that pyramid of pain, if you will. The defender's actual dilemma as to how do I defend against this? Being able to actually respond to a malicious activity. It doesn't always have to be malicious, right? It could be something governance, low-hanging fruit, like, hey, we're seeing Dropbox loaded on here, but we subscribe to OneDrive through Office 365. We shouldn't see any Dropbox systems in here. That's compromising an actual, against our ability to make sure that data stays in-house and not on somebody's personal drive. Being able to actually investigate that, right? Responding to it's one thing. Being able to actually prioritize triage detection and then start building up your documentation. But say you need to get into the investigation phase. Being able to actually take the data points that EDR, NDR, your application logs feed into your SIM. Validate, is it a true positive? Is this activity that we're expecting essentially to see inside our environment? Being able to thoroughly investigate that, the ability to powerfully search for it. And then hunting, right? So I used to call it threat hunting from the marketing side of the house. I call it hunt. When you're actually hunting, in most cases, you're actually talking to other divisions. Figuring out what they've been doing from activities. What new software have they released? What systems have they staged up in the environment? NetOps team, what firewall changes have you done? Has there been any request to route traffic from the outside inside? Do we have FTP servers sitting on the outside? Being able to talk to that team and then have a tool to be able to proactively hunt for undetected or even unknown persistent threats inside your environment that are acting like something that you would normally see. That's the threat hunt portion. The initial hunt portion, speak to your team, socially network through the team and figure out essentially what's happening. NDR provides you these 4 categories really to make sure that ultimately at the end of the day, you're able to confidently make sure that you're shoring up everything. And I would say if anybody tells you can 100% secure everything with all these tool sets, disregard that conversation. That's not true. There's always going to be threats that you potentially might miss. You just need the tools in hand to ultimately how do you respond and then ultimately investigate it against it. And if there's a capability to detect it right off the bat, it's even better. Once again, that's another thing that you can kind of check off the box and it's not on your shoulders. So let's take a look as to how, a network sensor extracts and actually starts to correlate data. So with NDR, it's a passive technology. It's not an agent-based technology. The idea behind it is that we are passively collecting a mirror of the traffic. For Gigamon core capability, like our tapping and aggregation visibility fabric, down to our ThreatINSIGHT platform. where you start taking a look at the network sensors and they're deployed in an environment, they passively collect the network traffic, for analysis. You're running things like Bro and Suricata underneath the hood and starting to actually do, payload analysis and PCAP tasking. During this analysis process, the sensor is going to ingest raw traffic, right? Not just flow and things of that nature. You really need to take a look at the raw packet itself and allow the sensor to do its job. And the sensor is just a medium, to transport the data. You extract the metadata, the payload, actually inspect the data actually necessary. Then, network events are created based upon this extracted metadata, right? What are the actual events that happen underneath that? You have an initial start of a conversation. Consider that a flow. If you're familiar with following a TCP stream in Wireshark, take that same concept and actually sessionize that. What events are happening underneath that? What are the different protocols? DNS, hellos, HTTP and HTTPS events, SSH, down to specifically who's logged in, NTLM, Kerberos. There's multiple protocols essentially you can actually start doing from a payload inspection and actually extracting the metadata from it. These events are a record of everything, right, happening on your network. They're really a foundation for threat detection capabilities. Like I said, the EDR has its point. It's going to tell you what's defined on the actual endpoint itself, but being able to have an actual record and a look back window as to everything happening across your network is invaluable. And then you still need a presentation layer for that. So really, once the metadata is extracted, it's then normalized, right? So you have to enrich the data. You need to start taking in things like, where is it located? Is this a country out of where we actually operate in our headquarters and our different spoke offices correlate to? Is it in a different country? What is the type of protocol? What's the type of event itself? Getting down to what type of indicators? Who's the actual host of this? Who's the ASN? Is it held by Chupa and Vulture, kind of low reputation? What is the actual reputation of the IP address internally as well as externally? And during the actual enrichment, you want to bring the intelligence from third party and our research team to really provide the context to events for analysis. We have a dedicated team of applied threat research, really tying this back into the Gigamon conversation here that we initially started off with. Our dedicated team really knows that when you actually start looking at different threat intelligence, it's not all created equally. And then when you actually start trying to correlate that to data enrichment and bring in the deep details that you need, you have to take a look at common properties as well as advanced properties to make sure that you're correlating that data together. This step, very important, all right, because actual enrichment information is extremely useful for an analyst to really perform the response and investigation actions. Being able to identify who is this system and ultimately where are they trying to go, right? There's a point A and a point B for every conversation. And having this information really at your fingertips during a responsive investigation cuts down on the time it takes to perform these actions. Improving the security operations team and just overall morale for the team. You're not having to look across too many different silos to be able to start correlating this data, because really the truth in most cases is in the network. So now it's on the how-to, right? The actual detection and analytics associated to this, requiring some sort of research, emulation. So threat detection should be an ongoing process. If you have a tool platform out there that basically says, no, we're going to release this detection, that's it. There's changes, there are iterations. Look at WannaCry. WannaCry started off of internal blue. It was a spinoff of essentially that. That was V1. Now you've got V2, and then you've got all these other, crypto lockers essentially out there. Look at crypto miners in their own right. Ethereum, Spectrum Swarm, manipulation of existing payloads that emerging threat was able to identify, but a lot of the times you might not be able to without identifying what's happening on the network, especially if you pull in things like Suricata association. In most of these cases, when you're actually deploying detections, it requires human interaction. Lots of researching, lots of prototyping, testing, and then managing the actual detection rules itself. It's a continual process, not just a one and done and kind of move on to the next thing. That's the case. You're not really focusing on the core issue, especially when you start identifying things as false positive. You need to know that that research team behind you is looking at why you identified it as false positive, especially when you put in good notes. And then from that, taking that back, re-researching it, and then re-releasing it in production, but ultimately still at test, right? Still taking a look across all the active customers that they have. And then when they start to see some positive traction on it, then release it to the customer again. Let them focus on things that are actually worth triaging versus just sitting there and releasing detection after detection. That's a good way that just a standard IDS does its job. Focus on the actual threat actor tactics and techniques. Taking a look at being able to actually stop and decompile the way that they got into the environment versus looking at just strictly anomalistic based data. Hate to be the bearer of bad news, but anomalies bubble up at regular points in time. Networks are weird. Internet's certainly weird. Those are not always direct indicators of malicious activity. Like I said before, they have their point, but if you can actually start looking at the threat actor tactics and techniques, a top-down approach, move that into something like what we like to call our dog food portal, where we eat our own dog food before we actually release it to the customer. We're doing our job. We're making sure that it's worth firing this off to the customer versus just sitting there and going detection by detection. Looking for ways of actually creating overlapping coverage, being able to see different multiple areas of rules firing off of the same activity, associating that across the actual network. It creates a better barrier for confidence. Being able to actually focus on the spectrum of detectable behaviors. Are we seeing this from day 1 to day 2? Is there a campaign that's specifically happening in an environment? You need to be able to overlap the technology that we've talked about today to really come to a full story and the end of the story. You don't want to just sit in the middle of the bridge. So now it gets into the how-to, right? How do we triage investigate? So when you actually start, ask a question, what is this threat trying to do? What is this detection trying to tell me? You have to be able to have the ability to investigate and get an answer. Well, inside ThreatINSIGHT, our NDR platform itself, we're all former practitioners. We felt the pain of being in this spot and having to go through too many different tools. And the reason that we built this is that we want to be able to ask a question, investigate forensically, and get an answer. I don't want to have to go back and forth to too many different places and too many different tool sets to really be able to corroborate this data. NDR really should be able to help you, to understand key questions such as what extended activities did the attacker carry out additionally in the environment. There's always that initial point where they're trying to exfil some form of data, right? Exfil or maliciously attack the environment to take it down. But then when you start getting into what are they trying to gain? Is there a monetary value? Sometimes what they might do, and we have one customer anonymized for this conversation here, they got in, they injected themselves through a web shell, taking a look at a vulnerability from the outside, and they said, hey, I can do a PHP injection. I now injected a web shell. Oh, I see lateral access because I've enumerated the network. Great. Well, they got what they thought that they were looking for, but what they also dropped additionally was a crypto miner. So they're utilizing the PC's CPU capabilities and RAM when machines would go into hibernate to start mining for Ethereum, Bitcoins, ultimately. That's the additional, right? You need to be able to understand additionally what do they carry out. So when tools only provide surface level context, you only get surface level remediation. Unfortunately, with today's attacks, it's not enough. Just stopping at an EDR and a firewall and a SIM, it's not usually enough. So when you begin your actual initial triage and investigation, we'll need to commence to the answer of who, when, and how of an attack. Typical questions that you always ask during a situation. When did this happen? Who actually interacted with it and how? So this is where ThreatINSIGHT ultimately comes into play. Our actual components comprise of 4 main components themselves. The sensor, really the transport area to start being able to actually get the data into our backend platform. So the sensors are running basic things like Bro and Suricata, file typing, things of that nature. They're really a means to an end. And ultimately, we look at it, we perform on both physical environments, your traditional data centers, so deploy a single sensor into the environment, cloud from AWS and Azure, utilizing the mirroring capabilities from Gigamon, and ultimately built-in capabilities from those different cloud providers, as well as virtualized appliances. You need to be able to scale to the areas that customers are moving to. And then we maintain the actual sensor itself. So the biggest thing for me that was a pain point in the past was having to not only maintain the tool, but ultimately try to put the roof out while it's on fire as well as investigating, as well as corroborating the data and answering those who, what, when, and where, as well as having an executive breathe down my throat, as down my back, as to what's happening, why are we not taking care of this? Well, sorry, I'm patching this, I'm carving this out. When you take that off your shoulders and you fully maintain the actual components that are underneath the sensor itself, that way you're just utilizing the tool and ingesting the data that we provide over to you. The data warehouse. So this is where most of the research power is going to be. If you actually broke a lot of the components apart from our data warehouse, you'd actually have to maintain those on your own. We take care of that for you. We're really trying to enrich the capabilities of an analyst, pulling in that network analytics and telemetry data. That way we're doing the correlation for you, and then can feed over to a SIM, and ultimately get you that context between both the EDR, NDR, as well as your application logs. On the analytics layer running on top of the data warehouse, you basically need to be able to identify, from a perspective, entity extraction. What is this machine? Is it a sales workstation? An IP address is a good start, but how can you actually associate a name to this? And being able to actually operationalize threat intelligence. Like I said before, not all threat intel, and most would probably agree, especially from the technical side, not all threat intel is created equally. You need to have a dedicated team to actually understand what's happening. And being able to actually build out those high fidelity detections and having a security research team backing that. I'd love to say every enterprise can build in their own security research team. That's a tough one to crack, especially when you're trying to get budget for a full-time employee like that. And lastly, our portal API. We know that we need to co-process with a lot of the existing, security purchases that the teams have made, up-level them more, provide them that actual analytics. Make something a little bit more lightweight and adjustable. We have our own presentation layer on our portal side of the house, but we are also fully built on a RESTful API. Interacting with core Gigamon to get you the data that you need, right? Feeding it over to us as a tool, and then ultimately for us to basically backfeed your SIM, being able to correlate that data. But we've also built the portal for practitioners by practitioners. We built it so that you can actually be responsive, reduce that dwell time, actually take real-time actions as the breach is happening versus after the fact. And really being able to integrate into things like a security operation security operation and automation platform like Azure to be able to respond to these actions automated versus having to do manual remediation on a regular basis. So kind of coming to the end, I'd like to leave 15 minutes for Q&A here, but some of the key takeaways that I like to pull from this really are NDR actually providing visibility where EDR and SIM cannot. Getting those areas that basically is that gap in between. Really, if you think about it, if you pictured it, you have EDR on the left, the full span, you have your SIM on your right. Your firewall is essentially above that. If you don't have anything essentially in between, you don't know what that actual threat is still carrying out inside your environment. You're collecting the right data is the first and most important step. Getting just generalized data points and pulling that in and trying to correlate across that, you're going to spend cycles trying to figure out, is there actually a threat inside my environment? How do I pull in all these different data points, and who is doing some pre-work before it actually gets over to my SIM? Having somebody else do a lot of the work ahead of time and identify those things. You need to have a dedicated team and rely on your vendor to do the right thing. You're enriching the data. Really, this is actually necessary. And I say that where in most cases you'll see a lot of open source tools out there provide you basic IDS logs. You can search through them, say through like an elk stack or something like that to gain a little bit of context. But once again, you're pulling in some general threat intel. You're not really associating passively what the DNS name of the device is. You need to be able to actually have that data enriched. Who logged into it via NTLM Kerberos? What's the passive DNS name? What's the DHCP address and MAC address of it? What's the base operating system? Android, iOS, Windows, etc. And are they serving up any vulnerable software? And then really automating the actual detection based upon the threat actor. What are their tactics? What are their techniques? Building a workflow within inside your team to actually be able to triage these and respond to the threats, and then being able to actually rapidly query against things that are unknown. The kind of quicker succession to basically being able to identify some areas that might not really fire off as a detection because they're manipulating something that you're thinking is a regular business process, day in and day out, and having that at your fingertips. Well, that's it for essentially, NDR, and our really run through as to building in that triad. So I hope you enjoyed this, but what I would like to do is open this up for Q&A. I'll hand it over to Tina and the team here to, kind of facilitate this, but I'm happy to answer any questions the team might have. And also, if there are any pre-populated ones in the chat, I'm happy to answer those as well too.